Our galaxy is hiding a violent past right under our noses. You are about to discover 25 secrets of the Milky Way that will shatter everything you thought you knew. We are going on a journey to uncover a cosmic home that is a cannibal, a warrior, and an ever-changing puzzle. By the end of this, you will see the night sky as a storybook of epic collisions and invisible forces. What is the colossal mystery pulling our entire galaxy toward an unseen point in the void? And why is our central black hole strangely overweight for its size? When you look up at the stars tonight, what story do you think they are trying to tell you? Our own galaxy is a cannibal in plain sight. It is currently devouring a smaller neighbor in a slow-motion act of cosmic destruction. The victim is the Sagittarius dwarf elliptical galaxy, a tiny satellite that has been orbiting the Milky Way for billions of years. With every pass, our galaxy's immense gravitational pull strips away stars, gas, and dark matter from this hapless companion, stretching it into long, shimmering rivers of debris that we can now observe wrapped around our galactic halo. This is not some ancient relic. It is happening right now, an ongoing feast whose evidence is written across the sky. These stellar streams are the galactic equivalent of crumbs left on a table, telling the story of a violent, ongoing meal. This process reveals a fundamental truth about how galaxies grow. They do not just form in isolation. They evolve by consuming smaller galaxies, growing fat on a diet of their neighbors. So what does this mean for our own future? The Milky Way's cannibalistic nature is a preview of an even greater collision. In several billion years, our galaxy is destined to merge with the Andromeda Galaxy, our largest local neighbor. That event will be the ultimate act of cosmic consumption, a chaotic and beautiful dance that will reshape both galaxies into something entirely new. The quiet, stately spiral we see today is an illusion. Our home is a dynamic, ever-changing beast, and its past, present, and future are all written in the stars it has consumed. But our galaxy's hunger is not its only violent secret. Two colossal, ghostly orbs are inflating from the very heart of the Milky Way, towering monuments to a cataclysm we barely understand. These are the Fermi bubbles, vast structures of ultra-high energy gamma raise that balloon outward for 25,000 light-years both north and south of the galactic center. To grasp their scale, imagine two enormous spheres stacked one on top of the other, stretching halfway across the entire visible sky. They remained completely hidden from us until just over a decade ago, when the Fermi Gamma Ray Space Telescope finally peeled back the veil of ordinary light and revealed this breathtaking architecture. Their discovery was a complete shock, proving that our galactic home is capable of eruptions on an almost unimaginable scale. So what created these titanic bubbles? The evidence points to a violent outburst from the very core of our galaxy. One leading theory suggests that our supermassive black hole, Sagittarius A star, which seems quiet today, experienced a monstrous eruption in the relatively recent past. Sometime within the last few million years, it may have devoured a huge clump of gas and dust, unleashing a pair of jets or an immense shockwave that blasted outward, inflating these cosmic balloons. Another possibility is a frenzy of star formation near the center, leading to a chain reaction of supernova explosions so powerful that their combined force punched these bubbles through the galactic halo. Whichever event was the true cause, the Fermi bubbles stand as a permanent scar, a recent and dramatic addition to our map of the Milky Way. They are a stark reminder that the calm we perceive is an illusion, and that the galaxy's heart can still beat with ferocious power. And these eruptions from our galactic center are not the only force pulling us through the cosmos. Our entire galaxy is caught in a river of motion, rushing toward a mysterious and unseen destination. For decades, astronomers have known that the Milky Way is not adrift. It is being pulled along with countless other galaxies at an astonishing speed of over 1 million miles per hour toward a specific point in the void. This cosmic target is known as the Great Attractor. The name itself evokes a sense of a hidden, powerful entity, a gravitational siren call from the depths of intergalactic space. For a long time, its true nature was one of the greatest puzzles in cosmology. What could possibly possess enough mass to command the motion of our entire galaxy and its neighbors? The search for an answer was immediately complicated by a simple but frustrating fact. The Great Attractor lies in the direction of the constellation Centaurus, a region of the sky that is hidden from our view by the thick band of dust, gas, and stars that forms the plane of our own Milky Way. This area is called the zone of avoidance because it effectively blocks our sight, like trying to see a distant mountain through a dense, personal fog. For years, this zone rendered the Great Attractor invisible to traditional telescopes, leaving scientists to wonder about the colossal secret hiding in our own cosmic backyard. How do you study something you cannot see? The breakthrough came with technology that could peer through the obscuring dust. Using radio telescopes and X-ray observatories, astronomers were able to map the large-scale structure of the universe behind the zone of avoidance. What they found was not a single monstrous object, but something arguably even more grand. The Great Attractor appears to be a colossal supercluster of galaxies, an immense knot in the cosmic web known as the Laniakea supercluster. Our own Milky Way resides on the outskirts of this vast structure, which contains the mass of over 100,000 galaxies. This supercluster is the true source of the gravitational pull, its combined weight creating a deep well in the fabric of space-time that we are all flowing into. Yet, even this discovery is not the final answer. The motion of our galaxy is so immense that the pull of the Laniakea supercluster alone may not fully account for it. There seems to be something even larger and more massive beyond the Great Attractor, an unseen structure in the distant cosmos that is tugging on us all. The mystery has deepened, reminding us that we are part of a cosmic current whose ultimate source remains just out of sight. This river of motion pulls us toward a future written in the past, a past that is literally shining down on us from the night sky. There is a star not so far from us that should not exist. It is called HD 140283, but astronomers have given it a more fitting nickname, the Methuselah star. When its age was first measured, the numbers were so shocking they seemed to break cosmology. The initial data suggested this ancient sun was older than the universe itself. How could a star be older than the cosmic event that created everything? That paradox sent scientists back to their calculations, refining their models and observations. We now understand the Methuselah star is not older than the universe, but it is a close call. Its refined age is approximately 13.7 billion years, placing its birth a mere heartbeat after the Big Bang. This makes it the oldest known star in our galaxy, a pristine relic from the very first generation of stars. To look at it is to gaze back at the dawn of time. Its composition tells the story of that primordial era. The Methuselah star is made almost entirely of hydrogen and helium. It contains only trace amounts of heavier elements, the metals that form planets and ultimately life. This pure composition is the key to its ancient origin. In the early universe, there was nothing else. The Big Bang produced only the two lightest elements. Every other atom in the cosmos, the oxygen you breathe, the iron in your blood, the calcium in your bones, had to be forged later. They were created in the nuclear furnaces of the first stars and then scattered across space when those stars exploded. The Methuselah star is a fossil from that time before such explosions. It is a second-generation star formed from the ashes of the very first short-lived stellar giants. Its survival for nearly the entire age of the universe is a cosmic miracle, a single, enduring witness to the galaxy's violent and creative infancy. While that ancient star witnessed the galaxy's first dawn, our own sun is tracing a far more recent path through the vast wheel of the Milky Way. Our entire solar system is on a grand, slow-motion carousel ride, completing a single orbit around the galactic center once every 225 to 250 million years. Astronomers call this immense cycle a galactic year. To grasp just how long that is, consider the last time the dinosaurs ruled the Earth. The cataclysm that wiped them out occurred roughly 66 million years ago. Since that momentous event, our planet has traveled only about 1/4 of the way around the galaxy. All of human civilization, from the first cities to the present day, has unfolded in a blink of a galactic eye. In the entire history of our species, we have barely moved a cosmic inch along our solar system's vast circular path. This timescale is humbling. It redefines our sense of time and place. We think of centuries as long and millennia as ancient history, but these are nothing against the slow, steady ticking of the galactic clock. Every orbit we complete is a chapter in Earth's deep history. The last time our planet was in this particular position in space, the continents were joined in a single landmass, and the first mammals were just beginning to emerge from the shadows. This cyclical journey is not a smooth cruise, however. As we orbit, the entire solar system bobs up and down through the plane of the galaxy, like a horse on a merry-go-round. This motion may have profound consequences, potentially exposing Earth to increased cosmic radiation or gravitational nudges from nearby stars at regular intervals. Some scientists even speculate that these rhythmic passages could be linked to mass extinction events in our planet's past, suggesting that our place in the galaxy might directly influence the story of life itself. We are not just passive passengers on a placid ride. We are moving through a dynamic and sometimes hazardous environment on a schedule so grand we can barely perceive its motion. The familiar pinwheel of stars we call home is just the visible tip of a far grander structure. Our entire luminous galaxy, with its billions of suns, is suspended within a colossal and invisible sphere of dark matter. This phantom halo contains over 80% of the Milky Way's total mass, a hidden gravitational anchor that dictates the very motion of everything we can see. Without this unseen scaffold, our galaxy would simply fly apart. We know it is there because of the way stars on the outskirts of the galactic disk move. They orbit the center far too quickly for the gravitational pull of the visible matter alone. It is as if you watched a child on a merry-go-round spinning at a terrifying speed, yet the central post was made of nothing but air. Something unseen, something immensely powerful must be holding on. That something is the dark matter halo, a cosmic ghost whose gravity is the only thing keeping those stars from being flung off into the void. This discovery fundamentally changed our understanding of the universe's architecture. The glittering spiral we photograph is merely the decoration on the surface of a deep, dark ocean. Scientists are now hunting for the particles that make up this mysterious substance. In laboratories buried deep underground, shielded from cosmic rays, incredibly sensitive detectors wait for the faintest tremor of a dark matter particle passing through. In space, powerful telescopes scan for the indirect signals of dark matter particles annihilating each other in the galactic halo. These experiments are probing the very bedrock of our cosmic home, seeking to identify the substance that forms the true skeleton of the Milky Way. We are living inside a giant we cannot see, held in its gravitational embrace, waiting for the moment we finally reach out and touch the invisible. High above the galactic plane, a ghostly river of gas flows across nearly half the visible sky. This is the Magellanic Stream, an enormous ribbon of hydrogen so vast it dwarfs the Milky Way itself. It does not shine with starlight, so you cannot see it with your naked eye, but to radio telescopes it appears as a brilliant, sprawling arc. This cosmic current trails behind two of our most famous satellite galaxies, the Large and Small Magellanic Clouds, like the long, ethereal hair of a comet. But this stream is no simple tale. It is a fossil record of a dramatic, multi-billion-year relationship, a story of gravitational attraction and violent encounters written in atomic hydrogen. The stream's very existence tells us that the serene dance of these dwarf galaxies around our own is far from peaceful. As they have orbited the Milky Way, our galaxy's immense gravity has been relentlessly pulling them apart. At the same time, the two clouds have had their own chaotic interactions, repeatedly crashing into and sweeping past one another. These collisions and tidal forces have ripped gas from their bodies, scattering it across the intergalactic void to form the magnificent stream we observe today. It is a celestial scar, a permanent marker of the violence that shapes even the smallest galaxies. Yet this scar holds the seeds of future creation. All that scattered gas is not lost forever. The Magellanic Stream is gradually falling toward the Milky Way, drawn in by the same gravity that created it. In the distant future, this river of primordial fuel will rain down upon our galaxy's outer disk. When it does, it will provide the raw material for a new burst of star formation, igniting billions of new suns and planetary systems. The destruction of the small clouds will ultimately give life to a new generation of stars within the cannibal that consumed them. This cycle of loss and rebirth is written across the heavens, a silent, ongoing transformation that will one day light up the galactic night. That serene pinwheel of stars we all recognize is actually an illusion. For generations, we pictured our galaxy as a simple, graceful spiral. The reality is far more dynamic and slightly off balance. The Milky Way is a barred spiral galaxy. At its heart lies not a gentle swirl, but a colossal, rigid structure known as the galactic bar. This bar is a dense, elongated collection of billions of stars, stretching an almost unimaginable 27,000 light-years from end to end. Imagine a gigantic candy bar spinning slowly at the center of everything, its ends connected to the galaxy's major spiral arms. This bar does not rotate like a solid object. Instead, it moves as a coherent unit, a gravitational whole that plows through the surrounding star fields. The stars within the bar complete an orbit around the galactic center in about 15 to 18 million years, a much faster rhythm than the Sun's own leisurely quarter-billion-year journey. This difference in motion creates a powerful and continuous gravitational tug-of-war. The bar's rotation acts like a cosmic paddle churning the inner galaxy. It funnels vast rivers of gas and dust inward from the spiral arms toward the galactic center. This forced migration of material is crucial, feeding the crowded central regions with the raw fuel needed to create new stars. Without this bar, the heart of our galaxy might be a far quieter and darker place. So how did we discover this central bar when we are stuck inside it? The proof came from patient, painstaking work. Astronomers cannot simply take a picture of the Milky Way from the outside. Instead, they had to become cosmic cartographers, piecing together our galaxy's structure from within. They meticulously mapped the distances and motions of millions of individual stars, looking for the subtle patterns that would betray the bar's presence. They found that in the direction of the constellations Sagittarius and Scorpius, the density of stars was significantly higher, creating that distinct, elongated shape. The final, convincing evidence came from tracking the stars' velocities, revealing that they were moving in unison, locked into the bar's rigid rotation. This discovery fundamentally reshaped our model of the galactic core. The center of our galaxy is not a symmetrical hub. It is a bustling, organized chaos driven by a spinning stellar engine, a secret architecture that has been guiding the galaxy's evolution for billions of years. Our galactic core is not just a feeding ground for a black hole. It is also a cosmic catapult, flinging stars out into the void. These are the hypervelocity-stars, lone suns racing away from the Milky Way at speeds so immense they will never return. They travel at over 1 million miles per hour, fast enough to overcome the galaxy's gravitational grip and fly off into the emptiness between galaxies. Each one is a runaway, a solitary wanderer on a one-way trip to nowhere. So what cosmic event could possibly give a star such a violent kick? The leading theory points to a gravitational slingshot of almost unimaginable power. Imagine two stars, a binary pair, orbiting each other as they fall toward the supermassive black hole at our galaxy's center. This is a dance that ends in a brutal divorce. The black hole's immense gravity captures one of the stars, pulling it into a tight, doomed orbit. Its partner, suddenly released from their mutual bond, is whipped around like a stone from a sling and flung outward at a staggering fraction of the speed of light. The captured star is consumed or imprisoned, while the other is ejected, becoming a permanent exile. These stellar outcasts are more than just astronomical curiosities. They are living proof of the ferocious forces at work in the galactic downtown. By tracing their paths backward, astronomers can actually map the invisible influence of the central black hole, using these escapees as probes to understand the monster that spawned them. Each hypervelocity star is a message in a bottle, telling the story of a close encounter with oblivion, a story written in its speed and its trajectory toward an eternal intergalactic night. The violent past of our galaxy is not just written in the stars it consumed, but in the very motion of those stars. A recent discovery has unearthed a galactic fossil hidden in plain sight, an event so ancient it helped shape the Milky Way we know today. Astronomers have named it the Gaia sausage. This is not a literal sausage, of course, but a distinct sausage-shaped grouping of stars when their movements are plotted on a chart. This bizarre structure was only revealed by the European Space Agency's Gaia spacecraft, a mission dedicated to mapping the precise positions and velocities of over 1 billion stars. What Gaia found was a population of stars moving in radically different orbits from the rest of the galactic halo. Instead of swirling around the center, these stars plunged toward the core on highly elongated radial paths like comets falling toward the sun. Their collective motion traces that peculiar sausage shape in velocity space, a ghostly signature of a cataclysm from the dawn of our galaxy. This stellar fossil is the remnant of a dwarf galaxy, one perhaps as massive as 10 billion suns that collided with the infant Milky Way around 8 to 10 billion years ago. This was not a glancing blow. It was a head-on, catastrophic merger that utterly shredded the smaller galaxy. Its stars were torn apart and scattered, their unique orbital paths preserved like a fingerprint in the galactic halo. The impact of this collision was profound. It is now believed that the immense energy from this merger did more than just add stars to the halo. It may have been the very trigger that created the Milky Way's central bar, that massive spinning structure at our galaxy's heart. The violent head-on impact would have sent powerful shock waves through the primordial gas disk, destabilizing it and causing it to buckle and reshape into the rigid bar we observe today. So when we look at that central bar, we are not just seeing a feature, we are seeing the permanent scar of a galactic trauma, a direct result of a merger that happened when the universe was barely half its current age. The Gaia sausage proves that our galaxy's most fundamental structures were forged in the fire of ancient collisions, a secret history written in the paths of long-dead stars. The galactic core commands all the attention, but what if you turned and looked in the exact opposite direction? This is the galactic anticenter, a point in the constellation Taurus that lies directly away from the brilliant, crowded heart of the Milky Way. You might expect this region to be a quiet, empty frontier, a simple backdrop of distant stars. The reality is anything but. The anticenter is a cosmic dumping ground, littered with the ghostly remains of ancient collisions. Here, astronomers have discovered faint, sprawling structures that weave through the darkness. The most prominent is the Monoceros ring, a vast, looping stream of stars that wraps around the outer disk of our galaxy. Another is the anticenter stream, a fainter ribbon of stellar debris. These are not part of the Milky Way's original design. They are tidal streams, long trails of stars ripped from smaller galaxies that ventured too close and were torn apart by our galaxy's gravity. They are the evidence of past meals, the galactic equivalent of bones scattered around a predator's den. The Monoceros ring is so immense that it actually passes through the plane of the Milky Way, creating a faint ring-like structure that we see from the inside. For a long time, its origin was a fierce debate. Was it a warped piece of our own galactic disk, flung outward by some disturbance, or was it the corpse of an ingested dwarf galaxy? The weight of evidence now points to a cannibalistic origin. The stars in the ring move differently and have different chemical compositions than the stars in the main disk, marking them as outsiders. They are the lost citizens of a galaxy that no longer exists, their community scattered into a great ring that now defines the galaxy's outer frontier. This means that even the emptiest-looking part of our sky is a historical archive. The antecenter is not a blank wall. It is a ghostly mural painted with the stories of ancient mergers that helped build the Milky Way into the giant it is today. Every time you look toward Taurus, you are gazing at a monument to destruction, a silent reminder that our galaxy's quiet edges are just as violent as its brilliant core. Deep within the galactic core, our central black hole is carrying extra weight. Sagittarius, a star, is surprisingly overweight for the size of our galaxy. In most spiral galaxies, there is a predictable relationship between the mass of the central black hole and the mass of the surrounding bulge of stars. Typically, the black hole accounts for a mere 0.1% of the bulge's total mass. It is a consistent cosmic rule, but our own Sagittarius, a star, breaks this rule. It accounts for nearly half of 1% of the bulge's mass, making it about 5 times more massive than it should be. This is not a small discrepancy. It is a glaring anomaly that forces us to ask a fundamental question. What happened in our galaxy's past that created such a disproportionately large monster at its heart? The most likely explanation is a history of excessive and violent feeding. While other galactic black holes might have dined on a steady, modest diet of gas, Sagittarius, a star, appears to have experienced colossal feasts. One compelling possibility is that it grew through a series of galactic mergers, consuming the central black holes of smaller galaxies as the Milky Way cannibalized them. Each merger would have been a cataclysmic event, funneling an immense amount of gas and stellar material directly toward the core, allowing our black hole to gorge itself and grow far beyond its expected size. Another scenario involves a direct and sustained flow of gas from the galactic bar. That massive spinning structure we discussed earlier acts like a cosmic conveyor belt, relentlessly driving gas inward from the spiral arms. If this flow was particularly intense in the past, it could have created a prolonged feeding frenzy for Sagittarius, a star, causing it to swell to its current, unexpected proportions. This overweight black hole is therefore a permanent record of a more gluttonous and turbulent youth. It suggests that the calm center we observe today is deceptive, the quiet after a storm of epic consumption. The monster at the heart of our galaxy is not just large, it is a testament to a uniquely violent history of growth, a secret written in the sheer, disproportionate weight of its gravity. These galactic geysers are a completely different kind of eruption. Unlike the gamma-ray bubbles that tower above and below the galaxy, these are vast outflows of million-degree gas and charged particles, blasting outward from the central molecular zone. This region is the most frenetically active star-forming nursery in the entire Milky Way, a place where stars are born in a frantic, continuous firestorm. The collective energy from all these newborn suns and their subsequent supernova explosions is so immense that it powers a cosmic fountain. It superheats the surrounding gas and blasts it out of the galactic disk in 2 opposing directions, creating these colossal geysers that stream for thousands of light years. Think of it as the galaxy's own built-in climate control. This process is a powerful feedback mechanism. When star formation becomes too intense, too chaotic, these geysers activate. They vent the excess energy and raw material out into the galactic halo, effectively turning down the thermostat. By expelling the very gas that would have collapsed to form the next generation of stars, the geysers prevent the central zone from burning itself out in a single, unsustainable burst. They regulate the pace of creation, ensuring that star formation can continue for billions of years rather than consuming all its fuel in a brief, brilliant flash. This reveals a galaxy in a delicate state of balance, where even the most violent processes serve a greater purpose. The chaos of birth is managed by an eruption, a self-imposed limit on how fast a galaxy can grow. It is a cycle of creation and expulsion, a breathing rhythm set by the furnace at the very heart of our Milky Way. Even our galaxy's star-forming nurseries are not fixed in place. They are part of a single, colossal wave rippling through the spiral arm we call home. This is the Radcliffe Wave, a recently discovered structure so immense it redefines our understanding of the Milky Way's architecture. For decades, astronomers mapped the locations of stellar nurseries, the dense clouds of gas and dust where new stars are born, and assumed they were relatively stationary features. The truth is far more dynamic. These nurseries are not scattered randomly. They are connected, forming a continuous, wave-shaped filament that is the largest gaseous structure ever identified in our galaxy. It stretches an astonishing 9,000 light-years long and 400 light-years wide, a gentle, sinusoidal curve weaving through our local spiral arm. This wave is not just a passive shape. It is oscillating, moving through space like a slow-motion ripple on a pond. The entire structure is undulating, with the gaseous clouds at its crests and troughs rising above and falling below the galactic plane. This motion was completely unexpected. What could have set this billion-solar mass structure into motion, causing it to ripple across thousands of light-years? The leading theory points to a violent disturbance in our galaxy's past. The most compelling suspect is a collision. A dark matter subhalo, an invisible clump of the mysterious substance that makes up our galaxy's halo, may have plowed through this region of the galactic disk hundreds of millions of years ago. Like a stone thrown into water, the impact would have sent a powerful gravitational wave through the gas, lifting it and setting it into the rhythmic oscillation we see today. This means the very cradle of star formation in our cosmic neighborhood is still feeling the echoes of an ancient, unseen impact, a ghostly tremor from a collision with an invisible object. The Radcliffe Wave transforms our view of the galaxy from a static map into a living, breathing entity, where even the grandest structures are in constant, rhythmic motion. This invisible architecture of dark matter creates a puzzle that challenges our most fundamental models of the cosmos. We call it the missing satellite problem. The most sophisticated computer simulations of galaxy formation, based on our understanding of dark matter, paint a very specific picture. They show that the Milky Way's immense halo should be bustling with thousands of small, dark matter clumps. Each of these clumps should have enough gravity to pull in gas and form stars, meaning our galaxy should be orbited by thousands of faint dwarf galaxies. The reality we observe is starkly different. To date, we have only discovered about 50 of these satellite galaxies. Where are the rest? This is not a minor accounting error. It is a glaring discrepancy between theory and observation, suggesting that something in our model of the universe is fundamentally wrong or incomplete. One compelling solution proposes that we are simply not seeing them. Many of these predicted dwarf galaxies could be so faint with so few stars that they are virtually invisible to our current telescopes. They would be mostly dark matter with only a handful of ancient, dim stars to betray their presence. Our galactic backyard could be swarming with these ghost galaxies hiding in plain sight. Another possibility is far more destructive. The early universe was a violent place, and the intense ultraviolet radiation from the first generations of stars may have sterilized these small clumps. This radiation would have heated the gas within them, preventing it from ever cooling down and collapsing to form stars in the first place. They would remain as dark matter ghosts, forever starless and invisible. Then there is the idea that our understanding of dark matter itself is flawed. Perhaps dark matter is not completely cold and slow-moving as in the standard model. If it were slightly warmer and moved faster, it would not clump together as easily on small scales. This would result in far fewer dwarf galaxies forming, neatly resolving the discrepancy. Each of these solutions points toward a different universe. Is our galaxy surrounded by a silent, dark multitude we cannot yet see? Or is the nature of the cosmos' most abundant substance fundamentally different than we believe? The missing satellites are an absence that speaks volumes, a quiet reminder that the darkest parts of our galaxy may hold the keys to its deepest secrets. Every star in the night sky carries a hidden chemical passport. This stellar DNA is written not in genes, but in the precise mixture of elements that make up its light, a code we can decipher using a technique called spectroscopy. When astronomers point a telescope at a star, they break its light into a rainbow-like spectrum. Etched across this spectrum are dark lines, unique absorption lines that act as a barcode, each one corresponding to a specific element in the star's outer atmosphere. By reading these lines, we can determine the star's exact chemical composition, learning what it is made of and, more importantly, where it came from. The most crucial clue in this cosmic ancestry test is a star's metallicity, which is simply the percentage of its mass made up of elements heavier than hydrogen and helium. In astronomy, any element beyond those two is called a metal, the material forged in the hearts of stars and their violent deaths. A star with very low metallicity, one that is almost pure hydrogen and helium, is a relic from the distant past. It was born from pristine gas that had never been touched by the alchemy of earlier stellar generations. It is a second-generation star, a direct descendant of the very first stars to ever ignite after the Big Bang. In contrast, a star like our own Sun has a much higher metallicity. It is rich with oxygen, carbon, iron, and silicon, elements that did not exist at the dawn of the universe. Our Sun is a newcomer, a product of gas that had been recycled and enriched by countless generations of stars that lived and died before it. This means the iron in your blood and the calcium in your bones were forged in the heart of a massive star that exploded billions of years ago, seeding the cosmos with the building blocks of planets and life. By measuring the metallicity of millions of stars, we are able to construct a galactic family tree. We can identify stellar siblings that formed from the same cloud of gas, and we can trace immigrant stars that were ripped from smaller galaxies and absorbed into our own. The chemical DNA of the Milky Way tells a story of constant growth and change, a history of endless creation written in the elemental signature of every single sun. This chemical map of the galaxy is superimposed upon a completely different kind of cosmic architecture, an invisible web of force that guides the very flow of energy and matter. We are living inside a vast and intricate magnetic field. This galactic magnetic field is not a simple bar magnet. It is a complex, dynamic network of magnetic field lines that permeates every corner of the Milky Way, from the deepest voids to the densest star-forming clouds. Its strength is surprisingly potent, 1,000,000 times weaker than a common refrigerator magnet, yet powerful enough on a galactic scale to exert a profound influence on almost everything. It acts as a cosmic guide rail for some of the most energetic particles in the universe. When cosmic rays, which are atomic nuclei accelerated to nearly the speed of light, come screaming across interstellar space, they do not travel in straight lines. The galactic magnetic field bends their paths, turning what would be a direct beam of radiation into a chaotic, spiraling dance. This magnetic maze protects planetary systems like our own from the full, blistering force of these particles, while also making it incredibly difficult for astronomers to trace these cosmic rays back to their violent origins, like trying to follow the trail of a ricocheting bullet in the dark. This invisible force also plays a quiet but essential role in the galaxy's grand design. The magnetic field is woven directly into the fabric of the spiral arms. Its pressure helps support the colossal weight of the galactic gas clouds against their own gravity, influencing how these iconic structures hold their shape over billions of years. More crucially, it is a master sculptor of star birth. Inside a giant molecular cloud, gravity is constantly trying to pull the gas inward to collapse and form new stars. The magnetic field provides a counterforce, creating a magnetic support that resists this collapse. For a new star to be born, the cloud must slowly leak this magnetic resistance, allowing gravity to finally win. It is a delicate cosmic tug of war where the magnetic field acts as a regulator, controlling the pace and efficiency of star formation across the galaxy. Mapping this invisible web is one of astronomy's greatest challenges. We cannot see it directly. Instead, we detect its presence by observing the faint polarization of starlight, a subtle filtering that occurs as light passes through clouds of dust grains aligned by the magnetic field. Other methods involve studying the radio waves emitted by electrons spiraling along the field lines at near light speeds. Each observation adds another thread to the map, revealing a structure that is both organized and chaotic, with field lines stretching across light years, twisting around spiral arms and funneling energy from the galactic core out into the halo. This magnetic skeleton is an integral, active component of our galaxy, a silent partner in the endless cycle of cosmic evolution. This local bubble we float within is not an empty void. It is a cosmic cavity surrounded by a ring of fire. Our solar system drifts in the calm eye of a storm of continuous creation and destruction. This ring is a necklace of brilliant stellar nurseries and the expanding ghosts of dead stars, a cycle of life and death on a galactic scale. Famous nebulae like the Orion Nebula are part of this fiery circuit, each one a glowing cloud where new suns are igniting from the ashes of their predecessors. The very existence of this ring points to a cataclysm that occurred long before humanity walked the Earth. Roughly 10 to 20 million years ago, a string of massive stars, all born from the same ancestral cloud, reached the ends of their short, violent lives. One after another, they exploded as supernova. These consecutive blasts were titanic. Their collective force acted like a cosmic snowplow, sweeping the interstellar gas and dust into a dense, collapsing wall that now forms the perimeter of our local bubble. This shell of compressed material became the perfect breeding ground for the next generation of stars. The shock waves from the ancient supernova triggered the gravitational collapse within these clouds, forcing them to contract and ignite into the brilliant young stars we see today. So the stunning nebulae we admire through our telescopes are not random. They are the direct descendants of a chain reaction of stellar deaths, a self-perpetuating cycle where star death leads directly to star birth. We are living inside the cleaned-out aftermath of a celestial demolition project, a project that is still actively building new worlds on the bubble's edge. The calm space around us was carved out by violence, and the beautiful ring of fire that encircles us is the ongoing echo of that long-forgotten apocalypse. The violence that shreds galaxies can also give birth to new ones. In the chaotic aftermath of a major galactic collision, something miraculous can happen. As vast rivers of gas and stars are torn from the wreckage, they can collapse under their own gravity to form entirely new small galaxies. These are tidal dwarf galaxies, and they represent a completely different path to galactic life. Unlike the vast majority of galaxies, which are thought to form from the collapse of immense clouds of dark matter, these newborns are born from the visible, baryonic matter of the collision itself. They are made from the recycled debris of a cosmic car crash. This unique origin gives them a critical characteristic. They are almost completely devoid of dark matter. For astronomers, this makes them pristine laboratories. By studying these dark matter-free galaxies, scientists can isolate the processes of star formation and galactic evolution that are driven purely by normal matter. They can ask fundamental questions. How does a galaxy behave without its hidden gravitational anchor? How do stars form and cluster when the dominant invisible mass is absent? The answers are already surprising. Tidal dwarf galaxies often exhibit incredibly high rates of star formation, blazing with the light of newborn suns ignited in the compressed, colliding gas streams. They are cosmic phoenixes rising from the ashes of destruction, offering us a pure glimpse into the visible universe's ability to create structure all on its own. In a cosmos ruled by darkness, these brilliant, temporary islands of pure light show us an alternate destiny, one written not in the shadows but in the luminous aftermath of violence. This galactic fountain is a self-cleaning cycle for the entire disk. When massive stars reach the end of their lives and explode as supernova, they do more than just scatter new elements into space. The sheer force of these detonations blasts million-degree gas out of the thin galactic plane, ejecting it high above and below the disk in vast, hot plumes. This gas travels for thousands of light years, climbing against the relentless pull of the galaxy's gravity until it reaches the halo. Up there, in the cold, sparse emptiness, the hot gas begins to radiate away its immense thermal energy. It slowly cools down. As it cools, it condenses, gathering itself into massive, dense clouds of primarily hydrogen. Now much heavier and cooler, these clouds succumb to gravity once more. They begin a long, slow fall back toward the bright starry disk below, accelerating as they plunge downward like celestial waterfalls. This is the fountain's return flow, a rain of cool, neutral gas that showers back onto the spiral arms. This cycle is the galaxy's ultimate recycling program. The gas that falls back is not the same as what went up. It has been enriched. During its journey, it has been seeded with the heavy elements freshly forged in the supernova explosions that launched it. This means the returning rain is rich with new metals, the very ingredients needed to form rocky planets and eventually life. This process continuously fertilizes the galactic disk, ensuring that each new generation of stars and planets has a richer, more complex chemical palette to work with than the last. Without this constant churn, the raw material for star formation would remain locked in the disk, growing stagnant. The fountain instead refreshes and enriches, mixing the products of stellar death back into the nurseries of stellar birth. It is a breathing rhythm for the Milky Way, an essential pulse that keeps the galaxy chemically alive and actively building for the future. Our galaxy is surrounded by a silent, dark multitude. These are the ghost-galaxies, hypothetical structures that could be the true solution to the missing satellite problem. They are not merely faint, they are almost entirely invisible, composed almost exclusively of dark matter with perhaps only a handful of ancient, dim stars or even no stars at all. These dark galaxies would be the pristine dark matter halos predicted by our simulations, but they never managed to light up. The intense radiation from the first stars may have heated their gas so thoroughly that it could never cool and collapse, or their gravitational wells may have been too shallow to hold onto the material needed for star formation. They would orbit our Milky Way as cosmic phantoms, their immense gravitational presence betrayed only by the subtlest of effects. How could we ever hope to find something that emits no light? The hunt relies on ingenious, indirect methods. One approach is to look for the brief, telltale flicker of a background star. If a dark galaxy passes in front of a distant star, its collective gravity could act as a lens, bending the starlight and causing the star to temporarily brighten in a specific, predictable way. Another method involves searching for the faintest possible smudges of light, ultra-diffuse galaxies so wispy and star-poor that they are barely there. The potential discovery of a true dark galaxy would be a monumental breakthrough. It would confirm that the universe is indeed teeming with these dark matter halos, just as our models predict, and that the missing satellites are not missing at all. They are simply hiding in the darkest shadows, a hidden population of ghostly islands whose discovery would finally allow us to study dark matter in its purest, most isolated form. This silent, invisible architecture may be the true backbone of our local cosmic neighborhood. Scattered across the galactic halo, far from their birthplace, a unique population of stars tells a story of celestial displacement. These are the splash stars, suns that were born in the orderly plane of the Milky Way's disk, but now swim in the chaotic depths of the halo. They are immigrants from the city, flung out into the countryside by a force of unimaginable power. For a long time, the existence of such stars was a mystery. How could a star peacefully orbiting in the disk be ejected so far from home? The answer lies in the gravitational shockwaves of ancient mergers. When a dwarf galaxy like the one that formed the Gaia sausage collided with the infant Milky Way, it did not just add its own stars. The immense gravitational disturbance sent powerful ripples through the entire galactic disk, like a stone thrown into a pond. These ripples were not gentle waves. They were violent oscillations that stirred the very fabric of the galaxy. For stars orbiting in the disk, it was like being on a calm lake when a tsunami hits. The gravitational shockwave gave them a tremendous kick, boosting their energy and altering their orbits forever. Instead of their neat, circular paths within the disk, these stars were thrown onto wildly eccentric orbits that launched them high above the galactic plane and deep into the halo. They are the splashes from that cosmic impact, literal stellar droplets flung out by the collision. Their chemical composition is the key piece of evidence that confirms their origin. Unlike the ancient metal-poor stars native to the halo, the splash stars are relatively rich in heavier elements. This metallicity fingerprint marks them as citizens of the disk, where generations of star formation had already enriched the gas with metals. They were born in a modern, chemically evolved environment, only to be violently evicted into the primordial halo. This discovery directly links a specific historical event, the Gaia sausage merger, to the dramatic reshaping of our galaxy's stellar population. It proves that these collisions did not just add new stars, they fundamentally redistributed the old ones, stirring the galaxy's contents like a spoon in a cup of coffee. The quiet halo is not so quiet after all. It is filled with the echoes of a long-ended collision, and the splash stars are its living, breathing witnesses. That serene, flat disk we picture is another cosmic illusion. Our galaxy is warped. The Milky Way does not lie flat like a perfect spinning coin. Instead, its entire outer disk is twisted into a colossal, gentle S-shape, flaring upwards on one side and downwards on the other, like a vinyl record left too long in the sun. This is not a small imperfection. This galactic warp is a vast undulation, a slow, graceful bending of billions of stars and immense clouds of gas that stretches across the entire visible structure. For a long time, we could not see this from our position inside the galaxy, but new, precise star maps have finally revealed our home's true, twisted shape. So what immense force could bend an entire galaxy? The prime suspects are our own galactic companions, the large and small Magellanic Clouds. As these dwarf galaxies swing around the Milky Way on their long, looping orbits, they do not travel through empty space. They are plowing through the immense, invisible halo of dark matter that surrounds us. This motion creates a wake, a gravitational disturbance in the dark matter, much like a speedboat creates a wake in water. It is this wake, this ripple in the invisible fabric of our galaxy, that exerts a persistent tug on the visible disk, pulling it into that distinctive warp. Think of it as a continuous, gentle pressure on the edge of a spinning plate, causing it to wobble and bend over time. Another compelling theory points to a more violent origin, a single, dramatic encounter in the past. A close fly-by from another galaxy, perhaps billions of years ago, could have given the Milky Way's disk a gravitational jolt, setting it into a slow, oscillating warp that has persisted to this day. The evidence for this lies in the motion of the stars within the warp itself, whose patterns can be traced back to a specific moment of disturbance. Whether from the constant tug of its satellites or the echo of an ancient collision, the warp reveals a galaxy that is not rigid but dynamic and flexible. It is a structure that breathes and bends, responding to the gravitational rhythms of its environment, a slow cosmic dance written in the twisted starlight of its outer rim. These galactic fountains and geysers are just one part of a much larger architectural phenomenon. Our galaxy is riddled with colossal cavities known as superbubbles. These are not small voids but gigantic spherical structures that can stretch for hundreds of light years, hollowing out the interstellar medium like cosmic Swiss cheese. They are the result of the most energetic stellar societies, where dozens of massive, short-lived stars are born together in a single cluster. Each of these stars burns fiercely, emitting powerful stellar winds, and then within a few million years, they die in a rapid-fire sequence of supernova explosions. The combined force of these continuous blasts acts like a cosmic jackhammer, relentlessly pushing the surrounding gas and dust outward, carving out an immense empty bubble. These structures are not just empty space, they are crucibles of galactic ecology dominating the structure of the spiral arms. The shock waves from their expanding walls sweep up and compress the interstellar medium into dense, cold shells. It is within these compressed shells that new clouds of gas collapse, triggering the birth of the next generation of stars and planets. Superbubbles essentially sculpt the galaxy's star-forming landscape, creating a self-perpetuating cycle where stellar death directly paves the way for new stellar life. We are not just observers of this process, we are living inside a prime example. Our entire solar system currently drifts through the local bubble, a superbubble roughly 1,000 light-years across. The very space that surrounds us, the relatively empty and calm region we take for granted, is the cleaned-out interior of one of these structures. The ring of brilliant star-forming nebulae that encircles us, including the famous Orion Nebula, is the glowing, compressed wall of this local cavity, a monument to the chain of supernova that carved out our cosmic neighborhood millions of years ago. This means the sky we see is fundamentally shaped by the ghost of a long-forgotten stellar catastrophe, a vast and empty chamber that channels energy and recycles material on a scale almost too large to comprehend. The final and perhaps most profound secret is that the galaxy is not just around us, it is us. Every single atom in your body that is heavier than hydrogen, every element that makes your bones, your blood, and your breath possible, was forged in the heart of a long-dead star right here in the Milky Way. The iron that carries oxygen in your bloodstream was created in the final, furious moments before a massive star went supernova. The calcium in your bones was fused in stellar furnaces that blazed billions of years ago. The carbon that forms the backbone of your very DNA was scattered across interstellar space by the gentle winds of aging red giant stars. These elements were then cast adrift, mixed into the great galactic clouds, and eventually drawn together by gravity to form our Sun, our Earth, and ultimately you. We are not simply inhabitants of this spiral of stars. We are the Milky Way, temporarily assembled into a form that can think and feel and wonder. We are stardust that has become conscious, and now, in a breathtaking act of cosmic recursion, we are using that consciousness to turn our gaze upward, to look back at the very galaxy that built us and to unravel its secrets. The story of the Milky Way is not just a history written in light. It is a biography written in the elements of our own bodies. We are the universe and the galaxy finally looking at itself. Our journey through these 25 secrets reveals a galaxy that is anything but the serene pinwheel we once imagined. It is a cannibal, a warrior, a shapeshifter, and a living entity built on cycles of destruction and rebirth. From the invisible dark matter skeleton that holds it together to the ancient stellar fossils that remember the dawn of time, every secret peels back another layer of a dynamic and often violent cosmic home. We have seen how our solar system rides a grand carousel, how our central black hole is strangely overweight from ancient feasts, and how our entire galaxy is warped and twisted by its companions. These are not distant, abstract facts. They are the story of our own origin, written in the iron in our blood and the calcium in our bones. The next time you find yourself under a clear night sky, I want you to look up. See it not as a static painting, but as a living, breathing storybook. See the cannibalized streams of the Sagittarius dwarf, the invisible pull of the Great Attractor, and the silent, waiting ghosts of dark galaxies. Let us know in the comments which of these 25 secrets change the way you see our cosmic home. And if you are ready to keep unraveling the wonders of the universe with us, be sure to subscribe for more deep dives into the cosmos.